So our today's topic is gravitation or gravity. So what is gravity? So after hearing this term, first thing comes in our mind that any body is falling down on Earth's surface, that is due to gravity. That means the force exerted by Earth on the body, that's why this body is falling down on Earth's surface, that is due to gravity. Right? Yeah, it's of course gravity. But is this all about gravity? No? Okay. So let's take this whiteboard. Let's consider this whiteboard is our universe. And we know universe having many stars, many planets, whatever. So if I take any two masses, maybe these are stars, maybe these are planets, maybe these are human beings or any animals, and as we know, we are also part of our universe. So these are any two non-zero masses, M1 and M2. They feel a force, that is attractive force towards each other. That means the force exerted by this body on this body towards this direction, that is attractive force. This body attracts it, and similarly in the similar forces, M1 is also attracts M2 towards M1, that is towards each other, right? So this is due to gravitational force, right? So gravitational force, if I take any two bodies having non-zero masses, this force is always attractive towards each other. That means if I take this is the first body, this is the second body, so the force experienced by first body due to second one, say this is F. So similarly, the force experienced by second body due to first body is also F. That means these forces are equal. So why not? This is universal truth. So why not? We can't see for Earth. Suppose if I take this is our Earth, and if I take this is an apple, so always we can see that apples always falls down towards Earth, but never Earth comes towards apple. This is not happen. Always you can see that apples is falling down. That means suppose if I take this marker, this is always falling down towards our surface, but Earth never comes towards this marker, because as you know gravitational forces are equal and opposite forces. So what's the reason behind this? So our answer, you can find it from Newton's second law. So Newton's second law, it tells that P equals to m into a. That means force equals to mass into acceleration. So if force is constant, then mass is proportional to 1 by acceleration, or acceleration is proportional to 1 by m. That means acceleration is inversely proportional to the mass. So if mass is lesser, acceleration should be higher, right? From this relation, if body mass is very very less, acceleration would be very very high. So for Earth case, suppose this is our Earth and this is an apple. As we know, mass of the Earth is much greater than the mass of apple. So that's why if mass is very very lower, acceleration should be very very higher. And for Earth case, mass is very very higher, so acceleration should be very very lesser, right? So that's why apple comes down by an acceleration, but Earth doesn't come. Why? Because Earth mass is very very heavier than apple. That's why acceleration of Earth we never determined, right? Now, how to calculate the gravitational force F between two bodies? Suppose if I take these two bodies here, say M1 and M2, and the distance between these two bodies is, this is R. Remember, this distance should be center to center, or center of mass to that body center of mass, where total mass is concentrated. This distance is not from surface to surface, right? Okay, just remember it. So the force, the universal gravitational force F is proportional to the product of these two masses, M1 and M2. And force is also proportional to 1 by the distance and that square. That means that is force is inversely proportional to the power 2 of R, that is distance between these two bodies. So if I combine it, that F is proportional to M1 M2 divided by R square. So if I remove this proportional into equal, then one constant is coming here, that is G m1 m2 divided by r square. So this is our universal gravitational force, and this G is called universal gravitational constant. And the value of G is calculated by Lord Cavendish. That value is 6.67 into 10 to the power minus 11. So what the unit of this G? So we can easily find it from this equation. G equals to F into r square divided by m1 and m2. So what's the unit of force? That is very easy. That is Newton. R means distance, meter square, and m1 and m2. The unit of first mass is kg, and unit of second mass is also kg. That means kg square. So unit of G, which is Newton meter square kg to the power minus 2, because this is in denominator, right? So this is our unit of G. So how can we calculate the force? Using this equation. Using this equation, you can easily calculate the gravitational force between any two bodies, any two non-zero masses of the body. So if I take any mass, say m1 equals to say 10 kg and m2 equals to 100 kg. So, and the distance between them r is say 10 meter, then you can easily find the gravitational force. That is G value is 6.67 into 10 to the power minus 11 into m1 m2, that is 10 kg into 100 kg divided by 10 square, that is meter, 10 meter, r value is 10 meter, that is 10 square. So if I calculate it, approximately we can get our result. Just neglect this value, just approximately we can say that is 10 square means 100, this 100 gone, 10 and 10 to the minus 11, that means nearly 6.67 into 10 to the power minus 10 Newton, minus 10 Newton. So you can see this value is very less, 10 to the power minus 10 Newton, that is very lesser than 1. That's why for any two smaller body, these are the very smaller mass, but for 10 kg and 100 kg also, even in for masses in ton also, they can't experience that force, that means gravitational force. That's why we can't imagine the force between these two, but it exists. Gravitational forces exist for any two non-zero masses. But for Earth case, as we know, mass of Earth is very large, that is 10 to the power 4 kg, right? 10 to the power 4 kg, 10 to the power 24 kg. That's why that force should be very larger, nearly 10 Newton or 100 Newton, like this. For Earth case, if this body mass, if I take is say 100 gram, and if I calculate gravitational force between Earth and then this body, this is a significant value of this force. It's still going a significant value. That's why we can feel that acceleration, because if force is present here, acceleration will come, right? So that's all for today's video.